I'm going to take a different approach to the four quadrants than I normally would with this, because we are in the middle of a lockdown at the moment, and I just want you guys to get through this essentially. Now this is probably the trickiest thing that we're going to do with trigonometry, because there's just a lot that's happening. Okay, but I don't want you guys to falter too much, because I think you can do it. Now, the four quadrants is basically talking about well, how do I put this? Like, trigonometry, when we did it in our last video, we were looking at angles between 0 and 180 degrees. Okay, well, now we can actually extend this to 360 degrees. Okay, so we kind of looked at this unit circle idea in our previous video, and we're essentially going to build on that. We're going to look at the first and the second quadrant. Okay, sorry, the third and the fourth quadrant now too. So what we're going to do is we're going to draw up this quadrant, okay, which we call the, and we're going to draw a circle in it. I'm going to call this the unit circle, because remember that it has a, oh, that's horrible, but that'll do, because it has a length of 1, okay, because it's a unit, or a radius of 1, I should say. Now, if I was to build up a right angle triangle, and let's use this quadrant on this corner here, okay. So remember, this is x and this is y, and if I'm moving in this direction in the x, I'm going in the positive direction, right? And over in this direction, it's the negative. And if I'm on the y, then this direction here is the positive, and this direction down here is the negative, okay? So if I was to make a right angle triangle somewhere on this circle, right? So it doesn't actually matter whereabouts I pick to do my line, okay? Our sine, cosine, and tangent ratios are going to change because of the sign of either y or x, okay? So let's start off with, say, this one, okay? Now, I don't care what the values are at the moment, okay? All I know is this is theta, this here is, it's y, and this here is x, okay? If I was to do sine right now, okay, so sine of theta is equal to opposite, which is y, over hypotenuse, and remember, it's a unit circle, so my hypotenuse is 1. So sine theta is equal to y, okay? Now, keep that in mind, because what I'm going to do now is I'm going to actually work out, or try to work out, well, what is sine over here, okay? Now, whenever we measure in the unit circle, we always measure from the x-axis, okay? So I don't want to make a triangle going like this, okay? This is a big no-no. I always want to measure my triangle coming down. And this is really important in a moment when we talk about our values, okay? Now, let's have a look at this one, okay? So the green one. So sine for this one, so sine theta is equal to, now, we've got our 1 value here, so our radius is always 1, okay, because it can't be negative or positive, because a circle can't have a negative radius. It doesn't make sense. But the direction in our x and our y that we've got does change based on our positioning, okay? So for my x value, I'm actually looking out this direction now. So I'm looking out this way, okay? So when I'm looking for my x coordinate, I'm looking out in this direction here. And that's in the negative x direction, right? So this value here is negative x. And when I'm doing my y value, okay, so when I'm looking for my y value for this part here, okay, when I'm looking for that y value, so this length down here, well, it's negative from the center, right? Because it's going down. So we can give this the value negative y, okay? So this time, instead of being positive y and positive x, we've actually got negative x and negative y, because we're in a different part of this circle, okay? Or in a different part of this plane. So sine for this particular circle, okay, sine for this circle, let's do it how we normally would. Now, our angle is always measured from here, okay? It's always measured from the x-axis, okay? So when we never use this one down here, we always use the one measured from the x-axis, okay? And it's opposite, so negative y over 1. So sine theta, in this case, is equal to negative y. So that's funny, okay? Now, think about the degrees of a circle, okay, we're going to call this side over here, okay, 0 degrees. Okay, we're going to start here. This is basically where we're starting our counting from, okay? So this here is my starting point, okay? And I'm going to start my counting from here. And when I count my degrees, I'm actually going to go anti-clockwise. So I'm going to go anti-clockwise, okay? So I'm going in that direction. So from this, you should be able to probably work out what each of my lines are going to be equal to, what they equate to in their in their degrees, okay? So if I'm looking straight up here, right? So straight up to the y-axis, okay? I've had to travel from 0 and I've had to travel 90 degrees. So this here is my 90 degrees. From 90 all the way around to the side will give me 180 degrees, and then around to 270, and then back again gives me 360 degrees. So this side over here, where my start is also my finish as well. Okay, so it's from 0 to 360, and we actually use both of those numbers. Okay, we use 0 and we use 360. Okay, and in fact, you can actually go further than that. But say if I wanted to do the next 90, so which would be 450 degrees. Okay, well that's just in the same position because I'm just doing an extra 90, so an extra 90 around this from my 0 degrees. Okay, so this is basically giving us an idea of what my sine, cosine, or tans are going to be based on what my angles are. Okay, so let's name these four things, these four areas. Okay, I'm going to call them quadrant 1. Okay, it's pretty boring names. Quadrant 1, quadrant 2, quadrant 3. Now, I don't want to write Q3 and Q4 because I don't want you to get confused with statistics. But these we call the quadrants, and we go around this way because this is the way we measure, okay? It's just convention, it's the way we do it. Now, there's some special things about these quadrants, okay? If you were to work out the sine, the cosine, and the tangent ratios in each one of these circles, in each one of these quarter circles, I should say, you're going to get a different value depending on which circle you are in. Okay, so we just looked before, well, sine in this one was equal to a positive number. Okay, I don't know what the number was, but it was positive. But over here, it was equal to a negative number. Okay, well, if I was to do it over in this corner, okay, it would be equal to a positive number as well. Okay, because if you think about it, my y direction is telling me what sine is. Okay, and y over on this side is going up. So sine theta would be equal to positive y on the side. Now in quadrant 4, okay, if I was to draw my triangle down here, okay, my angle, my sine ratio would be equal to negative as well because the value for my y is in that negative direction, okay? Now, you might be thinking to yourself, well, that's only for sine, and do I have to remember that, that sine is a positive value in the first and second quadrant and negative in the third and fourth? And what happens with cosine and tan as well? Like, do I have to remember all those? And the short answer is yes, you do, okay? And I'm going to show you a quick little, like a little rule that my Year 10 class 2 years ago came up with. Okay, it's very similar to the one that a lot of teachers use, but ours is just local to the area. So if your angle lies between 0 and 90 degrees, okay, all of the trigonometric ratios, so sine, cos, and tan, are positive, okay? Sine, cos, and tan are positive, okay? So if I put in, say, sine of 60 degrees, I'm going to get a positive answer back, okay? So they're all positive. Now, over on this one, okay, sine is the one that is positive, okay? So sine is positive, okay? So that means if I was to do sine of 150 degrees, because that's between 90 and 180, if I put sine of 150, I'd get sine to be a positive number. Don't care what the number is at the moment, but it would be positive. Conversely, if I put cosine and tan into this, I would get negative values in return. Okay, now think of, now if we were continuing around this circle, okay, this one is the tan side, okay, and this is where tan is positive, right? So if I did say tan of 200 degrees, and in fact, let's do it. Put it in the calculator. Tan of 200 degrees, if I pop that in, I get a positive answer out in return. But if I do any of the other two trigonometric ratios of 200, you'll notice that both of those angles are going to be negative, okay? So tan's the only one that's positive. So all of them are in the top right in quadrant 1. All of only sine in quadrant 2, only tan in quadrant 3. So you could probably guess what's going to happen in quadrant 4, and it's the cosine one, the cos. So cos is positive in this one here, okay? And so that's between 0 and 360 degrees. And again, we can verify that. Let's say cos of 350 degrees, okay? Put that in. Whoops. And you get, look at that, positive value. And it should be negative for the other two. So that's negative 0.17. And this is also negative 0.17. So that's really convenient. Excuse me. Okay, so how do you remember which ones are which? What's the quick way to do it? Now, I like to use this one. All stations to Coaldale. Okay, so a little bit like Sokotoa. All you got to remember is all stations to Coaldale, ASTC, and that will tell you what angles are in which one. So which ones are positive in which ones, and which ones are negative in which ones, okay? So I'm going to leave it at this for the first video, guys. All right, and I'm going to do a second video on how we can actually get an exact value in each of the different, in the different quadrants, okay?